Hello and welcome back to Python for Data Science by Utkarsh Minds. Let us continue our topic of statistics and data science. In this we will see what is the meaning of significance further, as well as we will see some other phenomena related to hypothesis testing. We have seen that data exhibits some research question. For example, coin tossed 200 times is fair or not. If heads is 192 and tails is 8. So this is our research questions. So that means we have taken a sample of 200 out of infinite, and we are saying on the basis of this sample what results we got about fair or not fair. We have to apply a hypothesis test. So our hypothesis says that H0 or null hypothesis and HA is the alternate. So null hypothesis says fair and alternate says not fair, and our hypothesis test says that we have got a probability of 0.05, which means 5%. This 5% means that if the coin is fair, that means reality coin is fair, but we are saying that no, it is not fair, then there is only a 5% risk of this happening. A 5% risk of rejecting a null hypothesis that is correct. So this kind of error is called type 1 error. But we can see that the probability of making a type 1 error is 5%, and we say that okay, 5% is not big number. So if whenever our p value is 0.05 or less, we can reject the null hypothesis safely. This is what hypothesis testing we will be doing this kind of hypothesis testing in the coming videos. We will create a hypothesis, null and alternate. We will check the p value, and if the p value is less than 5%, we will say null hypothesis is rejected. And that is what is the part of hypothesis testing. When null hypothesis is rejected, we say that we have a significant result. Significant result. It means that the population, that means if the coin is tossed infinite times, then also it will not be fair. It will still be a biased coin. So that was what we saw in the previous videos, a summary. Right now I want to discuss about the concept of normal distribution. Bell curve is what we call this kind of curve. Let us say that I have collected the marks of 100 students in an exam. So the marks are out of 100. So some students, they have got 10, 20, 25, 27, some have got around 50, some have got 60, 61, 75, 98 and so on. So if I collect all the marks of all the students, then I will find that I am getting a bell-shaped curve. So this is called as the normal distribution. We say that in mathematics several natural phenomena will exhibit this kind of a bell-shaped curve. Why is this important? The reason is that if we say that our data exhibits a bell-shaped curve or a normal distribution, 68% of all the people or all marks will be within one standard deviation of the mean. That means mean minus sigma and mean plus sigma. These are the limits in which we will find 68% of the people. Mean minus 2 sigma and mean plus 2 sigma will have 95% of the people, and 3 standard deviations from the mean will have around 99.7% of the people. So this is the use of our normal distribution. As what I said in my previous example, I have also written it down. Mean plus or minus 1 standard deviation is 68%, 2 standard deviation is 95, and 3 is 99.7. The use is that if someone tells you that your mean is 50 and your standard deviation or sigma is 10, so and you are saying that data is showing bell curve, which means that 50 minus 10 and 50 plus 10, that means between 40 to 60, in this limit of marks you will find 68% of the students. If you want 95% of the students are in which limit, then you can do 50 minus 20 and 50 plus 20, which is 30 to 70. In this range you will find 95% of the students, and 99.7% of the students will be 50 minus 30 and 50 plus 30, which is from 20 to 80. So that is the use. Even without looking at the data, you can say that if I am assuming a bell-shaped curve, majority of my marks will be from this and this range. That is the use of normal distribution. And even in the further videos we will see how this normal distribution is applied to data. Along with the normal distribution, there is also one more distribution known as the Chebyshev theorem, because the empirical rule we saw previously does not apply to all data sets. So this Chebyshev rule says that at least 3/4 of the data lie between 2 standard deviation of mean. That means in this range you will find 3/4 of the data, and in this range you will find 8/9 of the data. So a little bit different from the previous rule, but this is also a very respected theory in statistics. As I was talking about type 1 error and type 2 error, type 1 error, as I said, is the risk that null hypothesis is rejected incorrectly. That means reality is H0 is correct. This is the reality, but our research is saying H0 is not correct. That means there is an error. In reality it is correct, but our research is saying it is wrong. This kind of error is called type 1 error, and usually it is known as p-value or it is known as alpha. P means probability. Some studies usually we take as a thumb rule that if the p-value is less than 0.05 or equal to 0.05, we reject the null hypothesis, because this 5% is a very low risk of type 1 error. The opposite of this is the type 2 error or beta. Here we say that what will happen if we are not rejecting the null hypothesis even though it is incorrect, which means the type 2 error will be that null hypothesis is incorrect and this is reality, but our research is saying that null hypothesis is correct. This is known as the type 2 error or beta. So in conclusion, our interpretation of the word significance that we have seen that null hypothesis is an assumption about the population. If we get the probability value as less than or equal to 0.05, we will say null hypothesis rejected. That means null hypothesis, I am saying that it cannot be true. At p value, if it is greater than 0.05, we say that null hypothesis cannot be rejected. These are the two results that we get out of our statistical hypothesis testing. So whenever we apply statistical hypothesis testing, check the p value and either we reject the null hypothesis or we cannot reject the null hypothesis. Okay, so thank you for watching the video. If you have any comments, then mention in the chat and we will get back to you with the response. If you find any further suggestions, you can also send them to us through the chat below this video and we will respond to you. Okay, keep watching the further videos. We will start with practical exercises of implementing hypothesis testing and checking the results. Thank you.